All right, so we're back. Um, Today, I wanted to keep going down this DevOps rabbit hole, and I wanted to branch out specifically on infrastructure as code. So I'm just gonna grab this like this, copy that. Um, Excuse me. So can we like make it bigger? I don't know what the benefit is of making it bigger. I guess you can move things a bit better. Oh, but I don't want to grab all of that. I can do that. Shift add. Move. Okay, so infrastructure as code. More specifically, working with Terraform. But in order to understand the advantages of Terraform, you really have to kind of understand where CloudFormation and Ansible fit into the equation. So let's move each of these, and I don't know if I want to touch CloudFormation and Ansible just yet, so let's focus on Terraform. So what did we write so far? We basically wrote Terraform is used to consistently manage the state of your infrastructure. State files with Terraform plan. It's cloud agnostic, and so you can use it with any cloud provider, which is huge. But I still wanted to get into the detail, and I found this really good video of these Terraform interview questions, and it covers like a lot of different situations. So shout out to the DevOps dude, because this is a really solid video. It's like the best video that I found that basically covers every Terraform scenario that you would need to know the features of Terraform for. So for example, so off the bat, I want to take this and like transcript YouTube videos, and I'll pop it in there, get the transcript. Okay, so here's the transcript. Is that everything? Or I can copy it, and then I'm just gonna open a am I sharing my screen? Yes, I am. It does look like it. Oh, we're getting some mirroring happening. I just want to see where the limit is. Okay, so I'm basically taking the transcript, and I'm gonna say that every scenario from this video and so what's our goal with that? Our goal is to cover each situation. How do I want to organize this? So this is meant to be like a kind of big mind map. So I guess I'll put Terraform here. And then later we can cover CloudFormation here. I just want a free, because I know this is all gonna fill up. So um, we have these these 20 situations. Okay, so off the bat, we'll start really simple, which is, oh, we might be too zoomed out. I'm wondering if I should just use Excalidraw instead. Or maybe I should use the architecture. I don't know. Does this automatically scale the box down if it keeps going? Okay, I actually like that a lot better. Alright, now we're using Excalidraw. So we have Terraform, and it's okay because we're changing up strategy a little bit, but there's some benefits here. I think Terraform is purple, right? Should I do a quick sketch? Is this just to like draw? Okay, yes it is. I believe Terraform is like boom, 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 and then in a darker color, boom, boom, boom. Did I butcher that? Let's find out. Okay. I'm pretty satisfied with my memory on that. It's not great. It's not great, but it's not horrible either, so. Anyway. So we have Terraform. Now, each of these questions is basically associated with a scenario that you can find yourself in. Okay. All right. Here we go. What is Terraform and how does it work? So here's the question. So basically, what and why? There is a gnat. Hate gnats. Yes, I pronounced the G in gnat. So what and why? So maybe I'll branch this out. I kind of don't want to, but it's fine. So what and why? Well, that kind of comes down to like, what's the purpose of Terraform? Man, I'm just blowing chunks out here. It's crazy. So what and why? Why Terraform? Well, so far, what we know about Terraform is that it has a bunch of features, and I'm gonna put these features in a box, maybe a purple box. Nice, bunch of shades. And our first feature is something called a declarative model. Wow, that didn't really work. Oh, it's because like declarative model. Now, what is declarative model? A declarative model is basically the premise of Terraform in the sense that you get to declare the defined desired state. So instead of like saying like, okay, I want to do step 1, step 2, step 3, step 4, step 5, which is a very conventional programming approach, instead you're saying like, instead of saying I want bottom bun and then ketchup and then mayo and then patty and then whatever, instead you're just saying like I want a burger and it looks like this. You figure out how to do like each step and each details. So let's add some text to that. So the declarative model is basically defining the desired state, and it is not the steps. And so when it comes to implementing that, right, this is kind of, should I go back to black? I might go blue. Oh, I don't want to change this. Let's go blue. So when it comes to actually using that, we're talking about TF apply, also known as something is wrong with my shift key, also known as Terraform apply. And like this is the actual command that allows you to do what we're kind of describing here. So in order to define the desired state of what you want, you use Terraform apply. So that's what and why. Now, and you do tf apply. This is after you create a .tf file, which of course is a Terraform file. But then there's also the state file, which is like a whole other story. Now, the state file is, I was thinking maybe I can make a box, a blue box, and just to really make it clear like what the actual function is. TF apply background. Cool. Blue. Wow, Excalibur. I've been sleeping on this program, to be honest. I should have gave it more time of day. I might stick to this from here on out. I've been using Microsoft Whiteboard. Microsoft Whiteboard, man, what were the devs thinking? I really want to see like the agile story that was like, we're gonna make an app for whiteboarding, except it's gonna be really hard to use. There's gonna be a bunch of convoluted features. It's gonna be like so simple but so nonsensical, and layers are implemented, and like it's just crazy. Like I don't understand, like, how do people make these projects just like without thinking? I don't know. It's kind of a shame. I guess they're trying to copy Mural or Mural, whatever. So, did we answer the what and the why? So I think we answered the what. But now let's try to answer the why a little bit. And so, to answer the why, ultimately, like most things in the DevOps sphere, we want to ensure consistency. Let's do it like this. Repeatability and consistency, repeatability, and statefulness. Can I do italics? I probably have to click on it or something. Across deployments. So this is the why. This is why we want to do or use, this is why I want to use this declarative model. And this is why we're going to use Terraform apply and do the thing. Oh, my top fan is here. Hi, top fan. I remember when I was very young, and we started using the internet for the first time, we were terrified because like we didn't really know how it worked, but we thought like, okay, we paid a lot of money for a computer, we paid a lot of money for internet, and it feels like we pay more nowadays, which is the ironic part because back then it was cutting edge. Now it's just like everyone's got a computer like on their wrist, in their brain, in their pocket, on their desktop, in their living room, in the refrigerator, and the car. It's like everywhere. But so when it came to YouTube, and like people said like, subscribe to my channel, I wouldn't subscribe. And I really regret that. I wouldn't subscribe specifically because I thought it costed money. I thought it costed money to subscribe. Because the word subscribe sounds so like you're purchasing a service, like you're doing something. And so also I was thinking like all these people on YouTube are saying subscribe. Why? Like obviously they're asking for money. That's what I thought. So it's really funny in retrospect because I was so convinced that it was like some kind of a paid thing. And nowadays I get it. Hey, like, those YouTube ads, but there weren't YouTube ads back then. So I think back then people were just like saying subscribe just to like, you wanted the fame, like you wanted to build yourself up to be like Casey Neistat or something. But yeah, I just thought that was funny. So that's a joke. Don't donate. Just learn Terraform. No donate mode. Yeah, I think it's like a feature that you have to like enable or something. I turn on timestamps. No. Should say like, we'll write IC for food. So, welcome. So we're talking about Terraform, and we're talking about the what and why. And so basically, the what is this declarative model. And so the declarative model is basically HCl. And everyone knows that HCl is hydrochloric acid. For example, like this. Just kidding. HCl is HashiCorp language, which is the language of Terraform. Now, HashiCorp language, because Terraform is ultimately a HashiCorp tool. Let's grab a quick arrow. I'm gonna say declarative model. This is cool. Yeah, so HCL is the not everyone. Yeah. Not, you're right. You're right. Not everyone is well equipped for a chemical. That's what it is, right? It's like chemistry, I guess. Getting back on topic, so we have HCL, which is basically a HashiCorp language, and this is the language used to write like your TF file, your .tf file, and I would imagine that your state file also uses HCL. So yeah, in fact, I'm gonna move this here. I keep sneezing. Can I move this a bit like that? Cool. Right. So that's kind of the why and the what. Right? Now, this is kind of all for like a Terraform file. So, you know, I'll do this, and I'll also take it a step further, and I'll say, okay, how? Okay, so we know what we're doing, and we know why we're doing it, but how do we practically use this? And like, maybe this is a good framework for the rest of this video. But basically, we have two kind of core functions with Terraform here. We have our Terraform file. Can I duplicate? Duplicado. We have our Terraform file, and we have our state file. And should I go up or down? Would it be strange if I went up? I think it would be strange. So we have our Terraform file and our state file. Let's keep the flow logical. So the how of how we pull off this thing, this Terraform thing, is with these two components. This is so, the UI is so intuitive that like whatever I guess, like the way that you do things is like, that's just the way. Whereas with Microsoft, it is like, it's so backwards. It's so backwards. So we have Terraform file and state file. For our Terraform file, in which we use HCL, you create a Terraform file and you use the Terraform apply command. Can I bold this? No? I can make it bigger. Okay, I kind of like that. You know, I might make it green because it's a command going into terminal, so yeah, green is kind of cool. Now, when we talk about the Terraform file itself, we kind of know what it is. So we know that the Terraform file is infrastructure as code. Oh, we switched back to the yeah, so we know that it's infrastructure as code, and more specifically, it is ultimately resources for provisioning, right? But our state file is not resources for provisioning, and it's not infrastructure as code. Our state file, so for example, let's take Gemini out, and let's say the state file in Terraform is not considered infra as code, and it does not explicitly have the resources for provisioning. I mean, it does, but it has the resources, but it has not for provisioning. Instead, it has like a running history of the configuration of the Terraform file, as well as dependencies, as well as configurations. So describe this phenomena and give examples of how it looks. So in here, whenever you update your Terraform file, there's a back and forth between your state file and your Terraform file. And this process, from what I understand, is tf plan. Oops. Oh, I did something weird. TF plan. Maybe I'll make that black. This as well. So I wish I could change my default colors. Can I have it as purple? It's like this process. It's basically Terraform plan. Okay, you have hit on a critical distinction in the Terraform ecosystem. You're absolutely correct. The Terraform state file, terraform.tfstate, is not infrastructure code in the way that your TF files are. So you basically have a desired state and an actual state. And so your Terraform file is your declared model. So let's can I get back here? So this, we have .tf. Tough. We have, this is .tf state. So yeah, your TF is basically, it's kind of like what you want. So this is what you want in normal text, I think. What about code block text? I think it's fine. Yeah, so this is what you want. But we can't have nice things. Not all the time. And this is what you have. I really like that distinction. That's such a clean way to put it. Let's make these black. So this is human readable, version controlled, but your state file is kind of like the reality check, and it's basically a database that maps the resources defined in your code to the actual IDs attributed attributed to the real world resources created by the cloud. So it's kind of like expectation versus reality. But as you attempt to update your Terraform setup, your state file is always getting checked. And when they look at your state file, they're basically saying, okay, well, I know you want to provision this EC2 instance, let's say, but in your state file, maybe you already have one, or maybe there's too many. Like maybe there's a reason why it's kind of been like, how do I put it? Like sometimes when you do Terraform plan, it prevents you from doing certain things. So for example, let's say you want to like delete an instance and replace it with another instance. But the person who was managing the Terraform before you, they knew that this EC2 is really important and should not be deleted. And so they can kind of make some configuration where that's like locked so that you can't touch that. And then it protects it. And so when you use Terraform plan, you'll actually like run into that issue, practically speaking. So yeah, and we'll get into that. That's one of the questions that we wanted to cover. So the state file is an artifact, not a definition. You do not manually write the state file, of course. So the state file is like Terraform handles that. The TF file is what you handle, and it contains logic, but the TF state is basically a bunch of metadata. And so that's what I was kind of getting at. This contains metadata. This is written by Terraform, and this has resource mapping. So basically instance equals it's like the details, and it's written in JSON. Right. So this is like the bread and butter of TF plan and TF apply, which I'm gonna put that like that. Okay. I just need to do a water break. So I will be back. But yeah, so it's a really good like start. So this first one is a lot more high level, but the next 19 cases that I want to cover is specific situations about why Terraform is so useful and which commands need to be used in order to do that, and how all of that works. So for example, there's like HashiCorp Vault for secret management. There's like state locking with RDS, and like, you know, keeping your Terraform file in version controlled S3 bucket. Like each one is like a unique kind of situation, but yeah, so that's that. I shall return shortly. I'm just gonna grab some ice, my water, check my phone, a little bit of procrastination. There's no pot going on. تبريك تبريك تبريك. I'm back. So it is so hot right now. It's crazy. Okay, so I think we did a good job of covering what and why, as well as how. So this is one big component of Terraform that we covered. Now, what's next? Resource mapping, IDs. So let's talk a little bit about Terraform plan. And also, I'm gonna put this here. Basically, center front. Basically create, well, doing Terraform apply doesn't create a Terraform file. It applies your Terraform changes, but let's talk about Terraform plan. The 4-step process. Terraform basically wants to understand desired state. So I'll just say understand desired state, and it queries current state, updates .tf state with recent metadata, calculates difference, and then action plan to implement. This is all what Terraform plan does. Whereas on the flip side, how about Terraform apply? Maybe I'll keep it under after all. So Terraform apply. I see. So even if you don't do Terraform plan, when you apply, it automatically creates a plan. So it does its own TF plan. It just doesn't really give you the details, but it asks for confirmation. Dependency graph. I didn't know that. It creates dependency graph for parallel creation. So parallel creation versus sequential creation. Okay, so it uses providers, which is that's a key like Terraform concept. Use provider APIs. Updates .tf state file. So TF apply, it does what it contains TF plan. But the beauty of TF plan is like there are certain situations where I just have to kill another. I left my window open and now there's like these little tiny flies. I don't see them. Cool. So that's one valuable situation. Now here's another one. Now we're gonna get more into the modules. So let's go up. Is that weird? I feel like up is weird. Let's go down. How far? Maybe here is good. So over here I'm just gonna write how import manual resources. So this is another kind of how that we have. And we can put this in so basically, how do we import manual resources? Over here, I'm gonna put what is Terraform? Why do we use it? Okay, I like how this is turning out. Just move these a bit here. Cool. So how do it like this? What is Terraform? How do we use it? How do we import manual resources? So we can start again with what and why. So if we use what and why again, we can basically say like let's go back. So what and why? Basically, if we have resources that were not created by Terraform, but we still need them, we need to bring them in somehow. But of course, we don't want to just like, it needs to be in a controllable, consistent manner. I'll say stateful. I'll just throw around the word stateful because it's a fun word to use. We need to bring them all somehow, and it needs to be stateful. Now, how do we do it? Right? So if we get into the I don't like this capitalized here. We use a new command, which is called Terraform import. Whoa, that's not a good way to type that. So we basically use tf import, and what that allows us to do, this doesn't seem very extra large, to be honest. Why is this one so big? That's so weird. Anyway, so we use Terraform import, and so what this does is it does exactly what we expect, which is basically Terraform will map the existing resources to configuration blocks in our .tf file. And so why is this important? Because these are basically orphaned resources, so it brings orphaned resources under control, making them, doesn't make the resources stateful, but the approach to controlling the resources is stateful. And so it basically, it's for version control. It's for like better version control. And like if those, things go down, like do we want to keep deploying everything separately? Like that defeats the whole purpose of using Terraform. And so we want to control our resources with Terraform after all. So when we use Terraform import, in terms of the how, before we use Terraform import, we have to write a resource block. So like the current info, I'm sure we have to use like providers, Terraform providers. And then after we do that, after we write our resource block, then we can use Terraform import. And then what Terraform is going to do is map it to configuration blocks. Now, over here, we talked a bit about state file. And so let's just build off of this. I'll use red file. Red file, I'll use a red line. Where can I go? Let's go here. And let's say, just get like that. What if the state file gets deleted? So if your state file gets deleted, you may as well just retire from IT because you're cooked. Just kidding. You definitely screw yourself if you delete it. But in an ideal scenario, an ideal scenario is that your current state file got deleted. However, your most recent past state file is sitting in an S3 bucket. So basically, if you're already organized and controlling your state file, then go get the last one. But obviously that's not the whole story, right? Because if you lose your state file and it's not version controlled, then you need to do a re-import. So how about if I lose my state file and it is not version controlled? So basically, do not run tf apply, because this will just totally cook you. Maybe I should like put it somewhere here. And then when you lose your state file, you kind of go in a circle. And so since your state is essentially lost, everything must be re-imported using Terraform import. to do that, we know that one, we need to write all the resource blocks, manually capture each resource, and then two, UTF import, and then that basically takes you here, right? So actually that worked out well. I guess I put in a good spot. It's kind of cyclical. Okay, so we covered these situations. So I want to just go through the actual video and see how Mr. DevOps dude covers these
concepts to mock of by asking, what is Terraform and how does it work? You want to answer by saying something like, Terraform is an infrastructure as code tool developed by HashiCorp. It uses a declarative model allowing you to write concise configuration files that describe all aspects of your infrastructure, which could involve virtual machines, serverless functions, networking components, or entire application stack. When I run commands like Terraform plant or Terraform apply, Terraform looks at my configuration files, compares them with the resources actually running in the cloud, and then either creates, modifies, or destroys whatever is necessary to align the real environment with what I've declared in code. In essence, I simply describe the desired end state of my infrastructure, and Terraform figures out how to make that a reality, ensuring consistency, scalability, and repeatability at every single step. Another question you're likely to encounter once the interviewer knows you understand the basics goes like this. What is a Terraform state file, and why is it so crucial? You answer by explaining that Terraform state file essentially functions as Terraform memory. It keeps a detailed record of every resource Terraform manages, storing metadata like resource IDs, configurations, and dependencies. Every time you run a Terraform plan or an apply, Terraform consults this file to determine which resources need to be created, updated, or removed so that your actual infrastructure matches what you declared in your .tf file. It's also important to highlight that the state file can contain sensitive data like keys or private configuration details, which is why you should store it in a secure, remote backend with features like login and versioning. This setup not only protects the file from accidental overwrites, but also prevents multiple team members from making conflicting changes at the same time. By mentioning these precautions, you demonstrate your understanding of Terraform at a much deeper
Okay, so right there,
ensuring your interviewer sees that you should store it in a secure, remote backend with features like login need to be created, updated, or removed so that your actual infrastructure matches what you declared in your .tf file. It's also important to highlight that the state file can contain sensitive data like keys or private configuration details, which is why you should store it in a secure, remote backend with features like login and versioning. This setup not only protects the file from accidental overwrites, but also prevents multiple team members.
okay, that is a whole new scenario, which I'm gonna say, how do we protect the state file? How do we protect the state file? So, or first of all, why do we even need to protect the state file? Why can't we just go with the flow? So the reason why, first of all, we need to version control the state file for maintainability, repeatability, consistency, however you want to spell it. But also we want to protect the infrastructure from being deleted, overwritten, and specifically like prevent conflicts. So like if I make a change, someone else makes a change at the same time, then we're cooked.
Why you should store it in a secure, remote backend with features like login and versioning. This setup not only protects the file from accidental overwrites, but also prevents multiple team members from making conflicting changes at the same time. By mentioning these precautions, you demonstrate your understanding of Terraform at a much deeper operational level, ensuring your interviewer sees that you don't just know what the state file is, but also why properly safeguarding it is essential. Another common scenario your interviewer might present you with is this. Let's say there's a resource in the cloud that was originally created outside of Terraform is this. Team members from making conflicting changes at the same time. By mentioning these precautions, you demonstrate your understanding of Terraform at a much deeper operational level, ensuring your interviewer sees that you don't just know what the state file is, but also why properly safeguarding it is essential. Another, the state file can contain sensitive data like keys or private configuration details, which is why you should store it in a secure, remote backend with features like login and versioning.
Okay, so some buzzwords there: secure, remote, backend. And then our features are lock-in and versioning. So this is important. To do this in practice, you can use an S3 bucket, but the modern day thing to do is to basically put it in a DynamoDB2 table because it has state locking. So okay, so this is very like AWS-esque, you could say. Maybe I'll use like orange because my brain just works in AWS for this component. So for example, if you have an S3 bucket, let's duplicate that. And let's do DynamoDB. I flipped these. Yeah, so it should be like that. So what this allows us to do is by putting it in, by putting the state in an S3 bucket, we basically protect the state file, enable versioning, we can roll back if we need to. IAM is huge. Use IAM, protect state. Proper, I guess policies would be the right verbiage. And encryption. Encryption at rest. So basically if something horrible happens, S3 can kind of prevent something bad from happening. But the DynamoDB part is a bit more interesting. So by using a DynamoDB table, we can basically lock down the state file. So if there's a conflict, only one person will succeed. selected cannot be written. Right. And we can just move this a bit closer. So this is how we protect the state file.
This setup not only protects the file from accidental overrides, but also prevents mistakes. Let's say there's a resource in the cloud that was originally created outside of Terraform. The internal Terraform name and the real-world resource identifier point on any adjustments to that resource, right is, I'll have to import each resource using Terraform import so that Terraform can pass. Could you explain how to reuse the same Terraform configuration for multiple environments like dev, staging, and production? You answer by saying something like, one.
Okay, interesting. How do we use the same? Maybe it's bigger. We could actually like connect these at some point if we care enough.
Approaches to build modules containing the main resource definitions. Approach 2, how you handle diverse environments. They could ask, could you explain how to reuse the same Terraform configuration for multiple environments like dev, staging, and production? You answer by saying something like, with one best practices for safeguarding the Terraform state file are clear, the interviewer might pivot to how you handle diverse environments. They could ask, could you explain how to reuse the same Terraform configuration for multiple environments like dev, staging, and production? You answer by saying something like, one approach is to build modules containing the main resource definitions, then supply each environment, that is dev, staging, and production, with its own set of input variables for things like instance sizes, region settings, or naming conventions. This way, every environment relies on the same code base but can adjust specifics using variables. Another option is to leverage workspaces, which allows you to maintain separate files for each environment while still using the same .tl configuration. Both methods help to keep my code dry, consistent, and easy to manage, which is something interviewers value because it shows that you're thinking about scalability and structure from the ground up. After clarifying how to compare instance sizes, region settings, or naming conventions.
Okay, I really like that. We can move this. So you can use input variables to indicate specific needs for each environment, and this works really well for things like instance size, region settings, naming conventions, variables to indicate specific needs for each environment.
This way, every environment relies on the same code base but can adjust specifics using variables. Another option is to leverage workspaces, which allow you to
That's
maintain.
what I was looking for. Workspaces. So workspaces are a Terraform feature. Can I make this like purple? I still can't make the text bigger. I don't know how I did it for that first one, to be honest. Maybe I just got lucky. But anyway, so we can use Terraform workspaces.
Separate file base but can adjust specifics using variables. Another option is to leverage workspaces.
Leverage workspaces. Leverage workspaces. And that will allow us to do, how can we leverage workspaces. Use the same config in ISTUAT prod. So we can use Terraform dot workspace maybe I'll do this. Yeah, so leverage Terraform workspace. So define environment specific variables. Let's say we did that. Switch workspaces.
Which allows you to maintain separate files for each environment while still using the same .tf configuration. Which allows you to maintain separate files for each environment.
Okay, so this. Allows to maintain separate files for environment, and then but use the same .tf config for all
environments while still using the same .tf configuration. Both methods help to keep my code dry, consistent, and easy to manage, which is something interview
helps keep code dry, consistent. I want to change this to black. Where's the bar? If I close this, is it too big? Okay. I want to know how to make this bigger. Dev test prod.
viewers value because it shows that you're thinking about scalability and structure from the ground up. After clarifying how to handle multiple environments, the interviewer might want to test your grasp of Terraform's fundamental commands. They might ask, what's the difference between Terraform plan and Terraform apply? You answer by explaining that Terraform plan allows you to view the exact for anything mission critical or production related. How do you collaborate on Terraform projects with a much larger team?
Okay. I put that down as a future. Question. How do you collaborate on Terraform large team? This is like a question we haven't answered
You
yet.
might respond by saying something like, hey, if Terraform has created 30 EC2 instances, but you only need to remove a single instance, how would you do that without affecting the rest? You want it?
How do you remove specific instance?
Explain that you use the data to any kind of version control system. Instead, you explain that environment variables, HashiCorp board. How would you securely store database credentials or API tokens when working with Terraform?
Okay. So that's a really important one. Put it here. How do you protect? How do you protect secrets in Terraform? I'm gonna move this here, put that there. getting a little bit crazy. I want this to be like nice to look at. Kind of have to go far. I think it's the only way. Yeah, I think, yeah, it looks pretty good. On this side, this is alright, but we should follow our format. Man, this is way better than Microsoft whiteboard. It's not even close. It's not even like a question. Okay, I'm pretty happy with that. And then this will probably go here. And then we're probably gonna have another question down here. Let's move this. What else?
You could pose a question like, how would you securely store database credentials of API tokens when working with Terraform? Database model makes this relatively straightforward. In essence, I ask, how would you handle a situation where you need to create resources in both AWS and Azure?
Okay, multi-cloud deployments. How? Ooh. How do you create resources in different cloud? How do I word this nicely? AWS and Azure or GCP. How do you create users from different cloud? I'm trying not to use the word providers, but whatever. Like, screw it. Let's send this here.
Within the same Terraform configuration, to explain that, like, how would you integrate Terraform with a continuous integration and continuous delivery pipeline? Here.
Okay, it's huge. How do you do CI/CD with Terraform? Next.
In a well-controlled environment, you ideally restrict manual configurations. What happens if someone makes changes directly in the cloud console instead of going through Terraform? You'll explain.
Okay, that's like kind of a niche question.
Modules serve as self-contained packages of read. You might ask, why use Terraform modules and what advantages do they offer in large scale?
Okay, how do you use Terraform modules? This is a kind of like a deeper question of like, why would you use Terraform modules? This mind map is becoming a bit of a spider web, which I guess is a good thing. I hope though.
When would you choose count over 4 each and vice versa? You want
That's super specific.
When would you choose count over 4 each and
Count over 4 each. That's quite technical. When count versus 4 each in Terraform.
something like workspaces let me keep multiple save files. So something like workspaces let me keep more. Ask how do Terraform workspaces help in managing different environments? And when should
Okay. So this kind of expands to another question. I put it next to it. How do workspaces help managing environments? Next question.
I start my provision? Could you walk me through how you achieve a blue-green deployment using Terraform?
Okay. Blue-green deployment. Canary. How
How do you create before destroy and prevent destroy help in production systems?
Okay, so instead I'm gonna bring this here. I'm gonna bring this here. So how create before destroy, prevent destroy production systems. Kind of want to make this like bigger. I don't mind that it's coming out of the box. It's kind of cool. Just kidding, it's ugly. Terraform.
Covering how lifecycle meta arguments safeguard production environments, the interviewer might press further on ensuring quality. They could ask, how do you properly test Terraform code? You can answer by elaborating.
That is a great one. How do you... Well, I've reached the zoom out limit. I didn't know there was one, but... the whole point of Terraform plan?
What do you need to do if you need to migrate from Terraform 1.5 to 1.10? You answer by
Okay, I like what we got going on here so far. It's pretty intuitive. It's not too ugly to look at. I don't like the way these are fitting in. Maybe that should go like that. Yeah. That is what it is. Maybe only for that side.
saying something like testing and rollout procedures. Now that you've demonstrated how to handle version upgrades and maintain a robust infrastructure, the conversation might shift towards coordinating Terraform with other DevOps too. The interviewer could ask, if we rely on Terraform to provision servers, how do we integrate Ansible for application setup? You answer by saying something along these lines. Rely on Terraform to provision servers, how do we integrate Ansible for application setup?
So dang, we really gotta like kind of move out. Pretty sure that's the only way to cover everything. So, example, this can go here, and we can have one of these go out here, which is gonna be how Terraform versus Ansible production. Hopefully the answer to the CI/CD question is not too crazy. It should like fit. It's not great. It's not great. But what are you gonna do?
You answer by saying something along these lines. Terraform is great. As we wrap up, I hope these 20 scenario-based Terraform questions progressing from the most straightforward ideas to truly advanced.
These were amazing. Let's leave a comment. This is absolutely fantastic video. Thank you for preparing such an organized approach. Scenario-based questions regarding Terraform. I learned so much. Let's give it a thumbs up. And well, I already watched it. I don't think I need to save it, but what? Kitchen Terraform? Oh, maybe that's like the answer to that other question. Put this here. Okay, so we really haven't covered much in comparison to what is out there, but we still covered a lot. Like the main purpose Terraform, Terraform apply, Terraform plan, Terraform import, workspaces, state files, how they work, how to protect them, lock in, versioning. So I think I'm pretty satisfied with what we covered so far. There's a lot more, but Terraform is not a simple tool. I mean, in practice, I think what it proposes is simple, but when it comes to actually getting your hands dirty with the tool, it can do a lot, and that's the beauty of it, right? That's why we use it. So we shall continue our Terraform mind map and investigation, and yeah, hopefully this is helpful if you're tuning in, and if you're not, I'll catch you in the next one, or maybe I won't, who knows. But I think we did good. Peace out. Free Palestine.